Okay, we're in section 6.4 now, and before we begin to address some of these questions, there's going to be some information that we're going to want to know ahead of time in order to work through these questions successfully. Now, some of this we've talked about already, and we'll incorporate those ideas again. A few things are going to be new to us. Let's first consider what's called the slope formula. And we use the slope formula when we're given 2 points and we want to know the slope of the line that passes through those points. So if we're given 2 points, and we'll call those points, let's say, x1, y1, and then x2, y2. If we're given 2 points and we want to know what the slope of a line passing through those 2 points are, we say that we can calculate the value of m as being the following. We're going to take y2 minus y1 divided by x2 minus x1. Now, just a couple things to bear in mind. If you're doing this kind of calculation on the calculator, you're trying to do this in one foul swoop, you'd want to take whatever y2 is, minus y1, close the parentheses, divide it, and then take whatever your x2 value is, minus x1. And you want to make sure to put parentheses around that in order to calculate order of operations in a good procedure. So we're going to see how this formula is applied here in a little bit. This is a formula you're expected to know for the test. And it's one of those things that at the beginning of a test, you may want to have what's called a brain dump and just put it down before you need it, so that when you come around to a question that requires it, you know that bit of information. That's the first thing that we're going to want to know here. Secondly, we've looked at an equation of a line which is we refer to as slope-intercept form. And the reason we refer to these equations as being slope-intercept form, when they're written like this, is because we know that x and y changes on the graph of a line, but its slope and its y-intercept, that's where it crosses the y-axis, as we discussed in section 6.3 and 6.2, those are going to be fixed for a line. So if we have an equation written in this form, m, that's the value that's next to the x, that's always going to be our slope, and then b, that's always going to be the y-intercept. If we get an equation that is not written in slope-intercept form, then we're going to need to make the equation into this form. So I'll say that again. If we have some equation that's not written in this form, then we're going to need to rewrite the equation into this form. So that's the second bit of information. Now, the last bit of information I'll talk about is just going to be kind of quick here. So we're going to have 3a and then it'll be 3b. So if we have a horizontal line, so we have something that looks like this. Okay, remember this is a horizontal line. Okay, that's usually going to be in the form of y equals like some number. Then the slope of that line is going to be equal to 0. On the other hand, if we have a vertical line, and that's not going to be in the form of y equals some, that's going to be in the form of x equaling some number, then we say here that the slope is going to be undefined. So now if you can kind of hold on to this body of information here, this is going to help you a great deal. The only place that we may need to focus on sometimes is we may need to rewrite to match this. We may need to rewrite an equation to match this form so that we could obtain the slope and y-intercept by simply looking at the equation of that. So, as we go through the questions, this information is going to be most helpful as a base for doing the problems in section 6.4. Let's go ahead and take a look now. Here it says to find the slope of the line that goes through these given points. So they're not showing this to you in a graph, they're just kind of showing this information abstractly in question 1. So what I'm going to do is I'm going to take these 2 points here, and notice they're starting them right with all these negatives here. I'm going to label this one x1, I'm going to label this one y1, and I'll label this x2, and I'll label this y2. So I'm going to label those points accordingly. Next, what I'm going to do is I'm going to go ahead and I'm going to write out my slope formula, so I know that m is equal to y2 minus y1 over x2 minus x1. Now, for the purpose of accuracy, it probably isn't a bad idea to go ahead and watch what I'm going to do here. I'm going to put parentheses to put all of those values in, so I don't confuse the negatives that are part of the points versus the negatives that are part of the slope formula. So I create the space to put the information in, and now it's just going to be plug and chug. What's y2? Negative 3. What's y1? Negative 9. And then let's see, what's x2? x2 is going to be negative 7. What's x1 going to be? Negative 10. Now, if you're doing this by hand, you want to be careful of signage. If you're going to be using parentheses, you want to make sure you do the top first. Okay? Like, so what's negative 3 minus a negative 9? Well, negative 3 minus a negative 9 is like negative 3 plus 9, so that's 6. Then we have 7 minus a negative 10, like 7 plus 10. That's going to be 3. So we have 6 divided by 3. I'll bring that down here. And that value is going to be 2. So the slope of a line that passes through these points is going to be a positive 2. And that's how we're going to use the slope formula to do that question. I'm going to show this I'm going to show this one another example here, and then we'll take a look at an example for how we show the points when we find them on a plot. So do this one quickly because I'm coming a little short on my, oh no, I have some time left actually. Oh no, actually no, I don't have a lot of time. So here I'm going to label this one x1, y1. This will be x2, y2. And this time I'm just going to go straight to what I want to sub in without showing the formula since I've already written it above. y2 is equal to negative 2, y1 is equal to negative 1, x2 is equal to 6, x1 is equal to 4. So negative 2 minus the negative 1, that'll be negative 2 plus 1, or negative 1. 6 minus 4, that's going to be equal to 2. So if I have negative 1 divided by 2, that's going to give me a slope of negative 1/2. And that's not an unusual slope at all. That's actually a pretty common slope. Let's take a look at how we do a question like this for number 3, though. It says find the slope of the line, if it exists. And you recall we learned in class in section 6.2 that as I'm going left to right, since this is going down, we would expect that we should obtain a negative slope for this. So what I'm going to do first is I'm just going to go ahead and grab the coordinates of these 2 points here. So I'm going to write these coordinates down. So this first point, I'm going to get the one to the left, is going to be negative 2, positive 1. And this other coordinate is going to be 3, negative 5. So I'm going to put that down there, 3, negative 5. So I write those 2 coordinates down that are from the graph, and then from there I can label these x1, y1, and x2, y2. From here, I can go ahead and use my slope formula to put this information in. So y2 is negative 5, y1 is 1, x2 is 3, y1 or x1 is negative 2. So that's going to give me here, let's see, negative 5 minus 1 will give me negative 6. 3 minus negative 2 is 3 plus 2, that's 5. So it appears we have a slope that's going to be equal to negative 6 over 5. And just my quick math upon doing this tells me that that in fact is 4 is 5. So we're going to write the slope of this as being negative 6 over 5. You recall from our discussion just a moment ago, we were anticipating that the slope of that was going to be negative, and it turned out to be the case. In the case of question 4, let's take a look at this here. And if you need to stop and watch this again, that's fine. It says state whether the slope is positive, negative, 0, or undefined. So as you read this, we're going left to right now. The line appears to be going up. So we can say that's going to be a positive slope. Okay. Take a look at question 5 now. Decide whether the line given slope starts slants upward or downward, or is horizontal or vertical. So when they talk about upward or downward, that's what we're talking about. Remember, this is going to be left to right. So because this is a positive 6/1, we can say that's just going to be 6, which is positive. Therefore, we can say it's going to slant upward. Number 6, it talks about whether the given slope is going to be upward, downward, horizontal, or vertical. As I mentioned at the beginning of this, since the slope is equal to 0, that's going to be a horizontal slope. Number 7, given two lines L1 and L2, decide whether L1 or L2 has the greater slope. Now, by greater, they mean which one's positive. So if we look at L1, looking at L1 here, this is L1. This is the line that's going upward, therefore we could say its slope is going to be, you know what, I'm not sure about the answer to this, but I think what they're saying, because the slope is positive, and in the case of line 2, the slope is negative, we would conclude that L1 has the greater slope because of the fact that L1 is positive. It goes up as we go left to right, but that the other line is going down as we go left to right. The slope of this is negative. So that's going to be L1 in that case. In the case of number 8, they're asking which one has the greater slope. The question in this case is which one is going up faster. And if we go left to right, it appears that that line 2 here is climbing a whole lot faster than line 1 is. You can see back here that this line is lower at first, but at this point it surpasses line 1, so we can say that line 2 is the line that grows faster. Okay, here we have the graph of a vertical line. What axis does it go through? It goes through the x-axis. Where does it go through? At -8. So it goes through the x-axis at -8. And we could say that the slope of that line is going to be, because it's a vertical line, is going to be undefined. Therefore, the choice for that one is going to be an undefined slope. And that's number 9. I will leave you to do number 10 on your own to see what you could do with that one. What I do want to show you, there's a few more from here. Number 11. It says find the slope of y equals -9. Remember that in that case that's a horizontal line, and because of that, that's going to be 0. For the line, or for the slope of line x equals -6, that's a vertical line, so its slope is going to be undefined. That's going to be question 12. The last couple questions that I really want to get to are these last 3 here. I'll try to get these under the wire. So, what we're going to do in these questions is, in the case of question 13, it says to find the slope of the line. This is written in y equals m times x plus b form. The y-intercept is 6, but the slope is going to be -4. So from that form, we can see that the slope is going to be -4. It's the last couple questions that I want to kind of focus on because I want to focus on the rewriting of these. So here we have 4x plus y equals 3. By looking at this, I can't tell exactly what the slope is right away. But if I want to get it into what's known as y equals mx plus b, or slope-intercept form, I'm going to subtract 4x. And I'm going to move it to the opposite side. You may box it and move it over, but that's going to be y equals -4x plus 3. And now that it's in this form, we can say that the slope is equal to -4. You may want to try the last one on your own to see if you can get this, but this one's a little tricky, and it can be a lot of work. So we have 5x minus 3y equals 15. Watching signage on this is critical. I'm going to go ahead and subtract 5x. And when I have that done, that's going to give me -3y is equal to -5x plus 15. You'll notice here that I put the -5x first in the problem because I want to try to keep it in like y equals the slope times x plus b. But I need to divide everything by -3. So watch how I do this. This is divided by -3. This is divided by -3. This is divided by -3. That's going to give me then y equals. Negative 5 divided by negative 3 is just going to be positive 5 over thirds x minus 5. That's going to give us a y-intercept of negative 5 and a slope of positive 5 over 3. So rewriting the form of those equations is very important. The next part, do I have time? I can go over this. So, it asks us to determine whether the lines are parallel, perpendicular, or neither. This is probably a fact I should have included. My apologies. I'll make sure to include this letter. So, what we need to know for this is parallel lines. Parallel lines have equal slopes. Okay, perpendicular lines their slopes are what are referred to as opposite reciprocals. And okay, so for example, parallel lines having the same slope. An example of this would be to say that if one line has a slope of 5, another line has a slope of 5. But in the case of perpendicular lines, if one line has a slope of 2 over 3, then the slope of a line perpendicular is going to have a slope of negative 3 over 2. This is positive, this is negative, that's the opposite part. And then the slopes are going to be reciprocals of each other. This is 2 over 3, this is negative 3 over 2. So, when we compare the slopes, let's say in 16, this one is 5 over 4, this one's negative 5 over 4. They are opposite, but they're not reciprocals. So this is an example of neither. Taking a look, and I'll just do this last one for 17 here. I'm going to take the equation 5x minus equals 4y plus 2, and I have the other equation negative 15x plus 12y equals 2. I'm going to rewrite both of these. Now, you should probably practice this, but I'm going to do this quick as I'm running out of time to get this video done. I'm going to move the 4y to the opposite side. I'm going to move the 5x to the opposite side. That's going to be negative 4x equals negative 5y plus 2. If I divide both sides by negative 4, notice here when I move things, I just switch the signs on them. That'll give me, hold on, this is 4y, negative 4y, and that's an x. So I just changed that because I should have made that y, I should have made that an x. That'll give me y equals 5 over 4x, and that's going to be minus 1/2. So the slope here is going to be 5 over 4. In this one, I'm going to just add 15x to both sides. That'll give me 12y equals 15x plus 2. If I divide both sides by 12, and I have to divide everything by 12, I'm going to have y equals 15 over 12x plus 1/6. Now, y-intercepts are a mess, but that's not the focus. 15 divided by 12, that reduces to 5 over 4. So if this slope is 5 over 4, this slope is 5 over 4 because I take 15 over 12 and reduce that. The slopes are the same. That makes the lines parallel. That concludes the section video for 6.4.